Engineering capability and creative problem solving earned Baltimore District geologist Ethan Weikel the 2015 U.S. Army Corps of Engineers Innovation of the Year Award. Under his own motivation, Weikel developed and implemented an innovative soil testing system that is smaller and 75% less expensive than commercially available products, but comparable in effectiveness.
Adelphi Army Research Lab was the very first customer to ask us if we could do this type of testing for them, and they needed the results rather quickly. So we looked to see if this was available commercially, and it is, but it was too costly and too large to get within the time frame the customer needed the data. So we built this system and were able to implement it quickly and substantially more cheaply than we would have been able to get it from the private sector.
The tool determines how effective ground-sourced heat pumps can be at a project site. Using ground-source heating reduces building energy costs and provides a more efficient heating and cooling system.
We're here at the Baltimore District Soils Lab, and if we were going to install ground-source geothermal for a building like this, which would be a retrofit, it's generally a two-step process. First, we would test the soils by installing a loop either vertically or horizontally. We would circulate water through that plastic loop and measure the temperature as it goes out and it comes back. Once we know those properties, then we go to step two, and step two is installing a heat pump inside the building. And in the summer, that heat pump sends hot water or hot fluid out into the loop, and it returns having lost some of that heat to the ground. That's your air conditioning.
In addition, a similar unit has been developed for our Savannah district, taking into account the soil capabilities and properties in the southeastern United States. From the U.S. Army Corps of Engineers, Baltimore District, this is Clem Gaines.